Hello, my name is Panud Chamnanratanakul, and our project is license plate recognition. We decided to do this project because we found out that most parking lots in Thailand are currently using the conventional parking system, which requires contact between the driver and the worker when exchanging tickets. However, with the COVID-19 situation worsening, the system is not ideal. Therefore, it is necessary to implement the ticketless AI integrated system instead. This system utilizes license plate recognition to detect and read the license plate of a car. We are well aware that it already existed and commonly used. However, we are really interested in how it works. So we decided to simulate license plate recognition by using just a nano, a webcam camera, and a servo motor.
My name is Waritnan Kositcharoensuk. To recognize the license plate number, it can go through the following steps. In the first step, we open the Logitech webcam using OpenCV. Then, we capture the car image manually and save it into the data folder. Second, we resize the image to a grayscale and use a bilateral filter to reduce noise from the image. Third, we need to find the exact location of the license plate from an entire image. Edge detection is performed on the preprocessed image using Canny. Then we find the contour in the edge image and keep only the largest one. After that, we can loop over the contours and find the one that has 4 points. We can assume that the contour that has 4 points represents our plate, and then draw the box around the area of the plate. Next, we mask the part that is not the plate out and crop only the plate. After we know the exact location of the plate, we use the method called image-to-string in PyTestRack library to apply with the plate image. We configure the method by setting the language to be Thai and config value to be .psm13. The method will treat the image as a single text line. Finally, we control the servo motor to open the gate of the car parking lot. The servo will rotate only when the plate is detected, and the license plate number is recorded into the database system.
The first library that we are going to use is OpenCV. OpenCV is a library that is used for computer vision application. OpenCV can be used for object detection, face detection, and video processing and image processing. Therefore, we can apply OpenCV to the part that we want to recognize the location of the license plate in the image that we have captured. And the next one is PyTestRack model. PyTestRack is a wrapper to the TestRack OCR engine. This allows us to use TestRack OCR in the Python language. And now, let's understand what is TestRack OCR. TestRack OCR is an open source text recognition OCR engine. It can be used to extract text from image. This is a really effective model and can be used to detect license plate number from the plate image. As a TestRack uses deep learning LSTM, or you can call it a long short-term memory network-based OCR engine. LSTM is a kind of recurrent neural network which allows TestRack to read the whole line of text. But in contrast, if we use convolution neural network, it can only detect a single character, which is not suitable for our project, since we want to read the whole line of license number.
Now, we will show you our demonstration. As you can see, a car is arriving at the gate. The security guard welcomes the car. The system reads the license plate. And then the gate opens. The car goes through. And after that, the gate closes. Let's pause. This will be what happens if our system has sensors detecting that the car has arrived. However, our system is not automatic and our gate is not real. To run through our real case, to be fair, the only manual part is that we need to run the code for the webcam to take the photo. After that, the program will recognize the plate, and once it successfully reads the plate, the gate will open, and the car will be able to pass through. And here are our demonstration on other cars. As you can see, they both work properly. Lastly is our setup. Our gate is connected to the servo motor, and the servo motor is connected to the servo motor driver. And both the driver and webcam is connected to the tester nano. Tester nano is then connected to our laptop, which just in this clip is not plugged in.
Now, let's look at the result of this system. We'll see how well does the system work. Here, and in the experiment, I have tried 7 pictures of the car that was taken by the webcam camera and 19 more pictures of the car that I take from the internet. And here's the result. The result is shown below here, but it's really hard to look at. So I have made the Google Sheet to be easier to be able to analyze. Therefore, we can see that the accuracy of this system is 42.31% when include all pictures. But if we count only picture taken by the webcam camera, the accuracy go up to 71.43%. And why is that? First, the reason that I have thought about is that we don't know about the picture from the internet, if it is the original picture or if it is edited by the owner of the picture already. So that affect the resolution of the image, and so that might affect the accuracy of the system that we have done. But for the camera, we know we have taken the picture by ourselves, so we know what the original of the picture, and we can use the raw file. That's why it have better accuracy. Thank you.